Everyone. So in previous video, I tell you about the some concept or some topics, which is start from the matrix, basic of the matrix. Okay, so you can see here just in matrix definition and they explain it, and after that I multiplication and the trace of the matrix, transpose of the matrix, and determination of the matrix, and the adjoint of a matrix. So I describe all these topics in the previous video. So in this video I describe about the inverse of a matrix. Okay, so it is very it is depend on the previous topics, like adjoint and the determination of the topic they are used in this. Okay, so now start it. Okay, so uh, okay, I write all the things. So um, inverse of the it is 6 point inverse of the matrix. Okay, and it is also called the reciprocal matrix. Reciprocal matrix. Okay, like there is any matrix A, so the inverse of that matrix it is equal to A inverse. Okay, so we can write like this. So it is like I describe is like A square matrix. Okay, A of an order n is said to be invertible if there exists a square matrix B of the same order such that A B, okay, is equal to In is equal to BA. Okay, so if you don't able to know this, so when focus on this thing that there means we can do inverse of the matrix by two methods. Okay, by using the transport and adjoint and the determination of the matrix, and one method is we study in the 11th and 12th. Okay, so in this what we do, we use a formula. Which one? We take any matrix. Okay, after that we take I. So I means there is any is like one. If a matrix of 2 by 2, take 1 0 0 1. So we do these things. Okay, so I hope you remember these things. So and this method, okay, this method it this method is known as the Gauss-Jordan method. So this is simple, and when we use these things and we eliminate the rows and columns, either we eliminate rows, we make zeros, like we do like such things. In or A is equal to INA. Okay, you think you I hope you remember. We do there some things like we take two these like A, and we take this thing one. Suppose it is a 3 by 3 matrix and A. Okay, so there is any matrix like A B C D E F G H I. We convert this in this form. You know this thing, we convert it in this form, and this matrix, the final matrix after converting this matrix in this form, this matrix is known as the inverse of A. So I also tell about this form, this method. So first discuss about this. Okay. So now let's start. Okay. So I take an example like there is a matrix A, order 3 into 3. It is 0, 1, 2, 1, 2, 3, 3, 1, 1. Okay, so this is the our matrix. So now what I do, I need to find the determination of this matrix. So I also describe out this that how I find the determination of the matrix. So it is very simple. So for finding the determination of the matrix, I use this. It is indicate that it is the determination. So directly I used, okay, so 0 into 2 into 1 2 minus 3 into 1 3 plus 1. Okay, so 1 into 1 1 minus 3 into 3 9. So in determination what we do, it is not it is like that, first plus second minus, for other plus then again minus, then again plus again minus. So it is like that. Okay, so plus 2 into we take now 2 and now 2 and minus 6. Okay, it is 1, 1 into 1 is 1, no 2, sorry for this. So 1 into 1 1. Okay, so now it is 0. Okay, it is minus 1 into minus 8, it is plus 2, and it is minus 5. Okay, so it is minus, so it is 8, and it is minus, so minus 10, so it is minus 2. So minus 2, it does not is equal to 0. Okay, so now see here that what I do. So if I do one thing, what I need to find the adjoint of A. So here I find the adjoint of A. So this matrix is made, this matrix. Okay, so same thing I need to do in the to find the inverse of this matrix. Okay, so to find this thing, it is very easy, or I if we you can do yourself, and if so don't worry, I can do it. Okay, so adjoint of A. Okay, so adjoint of A is equal to, so where it is here. Okay, so we neglect these things, and we also use these things only. So 2 into 1 is 2, and 3 into 1 3. So 2 minus 3 minus 1. So one element is minus 1. After that we need to find here, so we neglect this thing. Okay, so 1 into 1 1, and 3 into 3 9, then 1 minus 9 is equal to 8, minus ka minus of 8. So now take it as a plus. So it is 8. So come on this. So it is now we'll neglect this thing. So 2, 1 into 1 1, and 3 into 2 6, and minus 6. So it is minus 5. Okay, so I take minus 5. Okay, first I take same outcome, then sign change, then same, then sign change, means plus plus minus, or I can say that first term is plus positive, and second negative, then again third positive, then fourth negative. So same thing is happen. So first is that, so it is positive, means same as coming outside from this, it is same. Then second is negative, then the output is negative, then negative and negative is positive. Okay, so third point is minus 5, then minus 5 into it is positive, so means it is same as it, like it is a multiplication of the upcoming number. Okay, so like just like that, first is come minus 1 into minus 8 into minus 5, so it is equal to minus 1, it is equal to 8 is equal to 5. So I hope you can do these things. So similarly I can also write for this. Don't worry, I write all the matrix, adjoint matrix. So again, now I neglect this thing, so this and this, so it is coming out 1, and after that I neglect this and this, so this one it is 0, and this one it is now minus 6. So now I neglect this thing, so this thing and this thing, so 0 and 3, so this is minus 3. So and similarly minus 1, and because minus 1 I neglect this and this, so 3 and minus 4 minus 1 similarly. Okay, so 2 and minus 1, it is the I can say that it is the cofactor. Now I need to, it is not adjoint. Okay, after that I need to, I can called it as a C, means cofactor of that matrix. After that I need to transport it. So for transpose we need to do these things, it is the sign of the transpose. Okay, so after that what I need to do, uh, we change the columns and rows. Okay, so minus 1 8, minus 5 1, minus 6 3, minus 1 2, minus 1. Okay, so it is the transport of this matrix C. Okay, so this matrix now it is known as the adjoint of A. Okay, so after that it is very now easy, we also find the transpose adjoint matrix A, and also determination of the matrix. So determination of the matrix is minus 2. Okay, so for finding the inverse of that matrix, so there is a formula, I think you know about this. So the formula is A inverse is equal to adjoint of A divided by determination of A. Okay, I think you know about this. So what is the determination of A? It is minus 2. Okay, adjoint of A is this matrix, so I can write adjoint like 1 by 2 and multiply by this. So this matrix is minus 1 1 minus 1 8 minus 6, 2, minus 5, 3, minus 1. Okay, so now I multiply this term inside. So A inverse is equal to, it is minus and it is minus, so plus 1 by 2, it is minus plus minus 1 by 2, minus plus 1 by 2, minus plus, it is 8 by 2, so minus 4. Okay, and the 6, then it is minus minus, so plus 3, 2, minus 2, minus 1, and it is minus minus, 5 by 2, 3, it is plus, it is minus, so it is 3 by 2, and minus 1, minus 2, so minus, it is plus, so plus 1 by 2. Okay, so it is the inverse of that matrix. Okay, of that matrix. So I remove all these unwanted things. Okay, so it is our main matrix. So I hope you can able to understand these things. So after that, I also told you about another method. So what is the name of that method? You know? So I think you know, and I think if you know, so then also if you make notes of these all these things, it is good for you. So now the other method is Gauss-Jordan method. I hope you listen this name in the 11th and in intermediate. Okay, so I also take an example for this. Okay, so we need to do this. So there is a matrix A. Okay, and it is also known as the eliminatory row operation, row and column. Okay, so it is based on you, but it is very long. The previous method is very easy. Okay, so now see, this is a matrix 1 3 1 2 5 2 3 1 minus 1 1 1. Okay, so I need to find the inverse of that matrix. Okay, so to find the matrix inverse of that matrix, so first I need to find the determination also. Okay, why we need to find determination? To after finding the determination, if the determination is equal to 0, then the inverse of the matrix is directly we do. Okay, or it is exist or don't exist. Okay, but the if determination of the matrix is equal to 0, then the inverse of that matrix is not exist. What if the determination of this that matrix are not is equal to 0, then that's mean the inverse of that matrix exists. Okay, so after that we need to find the So I need to find the determination of this. Okay, so we need to do first it. So directly I can do. So 1 3 1 1 3 1. Okay, and minus 2 2 and plus 1. After that plus 5 2 plus 3. Okay, so it is 2, it is minus 6, it is 25. So 21. Okay, so it is not is equal to 0. That's mean the inverse of that matrix is exists. Okay, if it is not, if it comes is equal to 0, this mean the matrix of that inverse of that matrix it not exists. Okay, so now see here I can write this. So now I eliminate the rows. Okay, so please focus here. I write a is equal to ia. Okay, so what is a? Now here it is 1 2 5 2 3 1 minus 1 1 1. Okay, what is I also told you 1 0 0 0 1 0 0 0 1. Okay, and it is a. Simple mean we transfer this matrix from here to here. Okay, means we need to make this matrix as a I. Okay, so now do. So apply R2 R2. This is R1, this is R2, this is R3. Okay, apply R2 is R2 minus 2 R1. Okay, so if I multiply by 2 in the R1 and subtract it from the R2, that after that this term is 0. So see here, and R3 is R3 plus R1. Okay, why it is plus, it is minus, so it is 0. So now the final matrix is come after this. So 1 2 5 it is same. So we first multiply in by 2 in this and subtract from this. Okay, so it is 0. Okay, and it is minus 1. Okay, and it is minus 9. After that add these two, it is 0 3 and 6. We need to do same things here. Okay, so if I do same thing, so it is minus 2 1 0 0. It is in plus, so it is 1. Okay, so 1 0 and it is 1. The next step is apply R2. We make one element as 0, so now we need to this as 1 and this as 0. Now first make it as 1. Okay, so we need to multiply by minus 1 in this, and after that I make this as 1. Okay, so see here minus 1 into R2, and R3 is 1 by 3 into R3. So I get 1 2 5 0 1 9 0 1 2. Okay, and here 1 0 0 2 minus 1 0 and 1 by 3 0 1 by 3 a. Okay, so I think you are able to understand till here. After that, now I need to make 0 this term and this term. Okay, so see here how I do. So R1 is R1 minus 2R2. Okay, if I multiply by 2 in this R2 and subtract it from the R1, then it is 0. Okay, so same, and R3 is R3 minus R2. So I get from here 1 0 minus 13 0 1 9, and after that 0 0 and minus 7. It's come like minus 3 2 0 and 2 minus 1 0, and it is minus 5 by 3 and 1 and 1 by 3. Okay, so it is a. So in next step I do next, and again, and I apply R3 is minus 1 by 7. Okay, so because I need to make it as a 1, so I get from here 1 0 minus 13 0 1 9 0 0 1. Okay, and it is minus 3 2 0 2 minus 1 0 and 5 by 21 minus 1 by 7 and minus 1 by 21. It is a. Now I again apply R2 is R2 minus 9 R3, and R1 is R1 plus 13 R30 R3. So after that I get as it is come 1 0 0 0 1 0 0 0 1. Okay, so it is equal to 2 by 21 1 by 7 13 by 21 minus 1 by 7 and 2 by 7 3 by 7 5 by 21 and minus 1 by 7 and minus 1 by 21. Okay, so it is a. So it is the our inverse of that matrix. Okay, so I hope you can understand this thing. So I also can write it like a inverse it is equal to this matrix. Okay, so thank you. I hope you can understand this thing. So thank you very much. I next video I tell you more about these things. Thank you.